CCS2301 Business Analysis and System Design module. And we are in the last topic actually about the module. We actually discuss from the beginning in information system design the main major steps, and then we right now talking about the system design phase of it. And last time under that, we discussed about the data design. Today, I'm going to talk about the system architecture point of view. And final topic, we are going to look at implementation and system support and security. So those are the topics we will have to finish the module. Right. So let's start then. Right now, under the system design, we now come to looking at the system architecture. And we know that from the beginning, when you say information system, we have hardware, software, data, and procedures and people. So everything comes under the system architecture. Now, once we talk about the architecture, we have the logical design into what we call the physical structure, which includes the implementation. So we have to, handle with hardware, software, and also all the processing methods. So when it comes to software part of it, you will have application programs, and then these are the programs which actually handles the input and also the managing all the processing, which means the processing logic, and also provide the required output. So the main outcome of this phase is to determine what should be the overall architecture to implement the information system. Now that we have the design, we should focus on the architectural perspective. Now, when you talk about the architectural choices, that affects a lot of things because for example, there could be some organization and there's a culture which affects the architectural choice. For example, now if the organization is more preferred to web-based solutions, maybe the architecture will base on that. And nowadays they can talk about host everything in a cloud and so on. Then we can also talk about ERP solution, which actually handles everything from beginning to the end. That means every detail of the organization can be planned using ERP system. And then another point that we want to focus on the initial and total cost of ownership. What it means basically, when you're developing a system, initially you have to spend some money to build the system, but then again to maintain, work with the system, also you have to spend some cost. So when you take everything together, we normally call the term total cost of ownership, which is what we need to focus on, again, which affects what architectural choices we are going to make. Fourth one is scalability is an important factor, because you know that nowadays information systems, especially now cloud-based system where you open it up to hundreds of thousands of users, when the user numbers increases, your system should be able to handle it. So your system should be able to easily scalable to the growth of the number of users. So scalability is another architectural choice you need to consider. Fifth one, web integration. Again, more or less nowadays everything on the web. I think web integration is an integral part of information system, not like in early days where our focus is only for developing desktop application. Now we are moving towards the web, especially web and the mobile, and those are also some of the issues that we have to think of. The legacy system interface requirements. Okay, this comes into picture, especially organization has some legacy, older system, information system. You know that if you look back in countries like Europe, initially their e-commerce systems were built using a programming language called COBOL. and still those systems are in place, right? So remember that although we develop new information system, there should be a interface to these legacy systems, because a lot of data is already stored and you cannot ignore them. Then processing option is another issue. Security issues, again, nowadays the implementation details more towards the cloud-based systems. So when it comes to data in a third party, we have to think about the lot of other security issues as well. And finally, corporate portals, again, which affects the architectural choice. So let's look at some of the architectures available from early days. What we have is usually we had mainframe architecture. In mainframes, especially in the architecture, you have servers and the clients. And the servers are one who supplies all the data processing services to other computers. In traditionally all computer system, what we had the mainframe, which performs all the processing at the server level, where a client are kind of a dummy where they just connect to the server for the processing. So this figure briefly describe how mainframes works at that time. So the client computers are known as a terminal. They are using these terminals, people can connect into the mainframe where the main processing happens within the mainframe computers. Now we know that the most of the systems were based on client server architectures. So and typically, when you look at these client and server architectures, so the client represents the user interface, and I hope you already familiar with the client technologies where you think about the presentation. And data validation, for example, data querying, presentation logic, these are handled within the client side, where the backend or the server side, you will have the actual data processing and database access and database management, functions. Now, there are some business logic, or sometimes we call application logic, should be in between the servers and the clients. So typically, you can what happens is a client make a request, and the request will be processed within the server, and then you will get the result back. So that's how usually client server architectures works. So for example, in this figures, represents the client request. So usually client send some query to the server. Processing happens within the server, especially with the database. Usually you have a database backend, and then the results will be transmitted back to the client. Now, when you compare like traditional mainframe systems with the client server systems, just you should know the difference. Simply the basic architecture client server is very flexible, but in mainframes are very rigid, which means you cannot change the structure. When it comes to application development, client server is flexible, fast, and usually object-oriented. Mainframes, traditionally, they are highly structured, they were slow, and the traditional. The environment is, you will look at both client server and mainframe. In user environment will be PC-based graphical user interface, empowers the user and improves the productivity. Whereas mainframe computers, we usually have what we call the terminals. And those days, we didn't have any graphical user interfaces. We have just text interfaces, mainly command-based or text-based input were used. So there's no user friendliness or constraints where the limited options were there for the user to interact with the system. Security and control features, usually client server decentralized and difficult to control because of that reason. But the mainframe always it's centralized and it's easy to control because of this centralized manner of accessing the server. Processing options can be shared and configured in any form desired. Sharing is easy, but in mainframes, it was not like that. Cannot be modified. When you look at the data storage options, the data can be distributed. The place data close to users. Now, for example, if you have done data distributed systems, you know that when you have a database where the data is distributed geographically, usually we keep the data close to geographical locations. Now, for example, if you have an application where you have several countries are participating, particular data related to that particular country can be put into the machines in that geographical locations. But in mainframe system, usually data is centrally stored, which is kind of a problematic in nowadays, especially in a distributed environment. Hardware software integration is very flexible, multi-vendor model, which means that there are many vendors which supplies the client and server architectures. But mainframes were very rigid, and then usually it comes from the single proprietary vendor, which we don't have a lot of options per se. We have to select, those who actually manufacture in the mainframes. Right. Now, when it comes to client-server architectures, especially when you look at the clients, there are two types. One we known as flat clients, and the other one is known as thin clients. So the fat or thick meaning like most of the processing, it's actually happens in the client side, and thin client, you have everything will be in the server. Now, for example, if you look at the banks nowadays and those, the front office, the users, they mostly using thin clients, which is the computers are not with the processing power. Very limited processing power is there, but everything happens centrally, right? So thin clients can be used, right? But flat clients, most of the time you can do a lot of processing. And then these flat clients usually often engage in, updating the data. Right, just to compare some characteristics between the fat and thin client. Fat, I told you, like there's a lot of processing can be done in the client side. Thin client, they are barely, sometimes we use like kind of dummy terminals. Very limited processing will happen within the thin client side. So network traffic, fat clients is higher because fat clients has to communicate more often with the server. Thin client is lower because interaction is very limited because a lot of processing happen in the server side. If you look at the performance, fat clients are slower because you need more network traffic. But the thin clients are fastest because network traffic is very minimal because it needs a network just to communicate with the server. Third one, if you compare with the costs, usually flat clients are higher because more powerful hardware is required. You need more processing power, more memory, more space. But the thin client, you don't need anything. I mean, most of the time, thin clients nowadays, what you have is a browser and maybe an internet connectivity. Easy enough, which means you don't need the processing at all. Very minimal processor and memory is enough. Next one is the maintenance cost. Usually in fat client is higher because more program code resides on the client side. But in thin clients, it is very low because none of the codes are reside on the here, but everything should be in the server side. Now, as a final one, if you look at how easy to develop, fat clients are easier and thin clients actually more difficult. Right. Now, the next one is when you talk about particularly client-server architectures, there are several designs. At least we can talk about two designs, the two-tier, whereas you have client and server side, and application logic can be in one of these, like either client or the server side. Second design is 3T designs. That means you have a client and a server, and then for application also, we can have another layer, which we call application server. So this is possible with 3-tier design. So here is the graphic which talks about this. So usually we will have data, application logic, and the user interface, right? The data will be in the server side and usually interface in the client side, right? Application logic could be in both the sides. So you can see 2-tier architectures, usually data will be in the server side and the user interface in the client side. Your application logic is shared between both server and the client. Next, if you look at the 3-tier architectures, we have three parts. So you have a separate server dedicated for application logic. So this is called application server. So usually we have data server for handling the data, application server for applications, and then we have a client in the client side. Right. Just to compare like the possibilities. So we talk about several ways of handling server and clients. Let's look at like central data processing center. What it means is everything will be reside on the server side. So you can see this cross in towards the server. So the data, application logic, user interface, everything handled through the server side. Then the second one is you can have a central server with the remote terminals. Now, when you say remote terminal, what it means is the user interface in the client side, but the data in the application logic could be in the server side. Third one, you can have standalone clients. Standalone client means everything will be in the client side. Your data, your application logic, and user interface, everything. If everything is in the client side, we normally call it as standalone client. Two-tier client server architecture, we already discussed the idea. So your data and application logic, and application logic and user interface. So the server handles both the data and application logic, and the client handle application logic and user interface. So what it says, basically application logic is separate between server and the client. Last one, we call it 3-tier client server architecture. Usually we have a data server which actually store the data, and application server where the application logic is presented, and finally user interface in the client side. So these are some of the architectural choices you can make depending on your requirement. Right. Now, with the internet, you can see a lot of impact on the system architecture. Now, especially, we can talk about things like e-commerce architecture. So in e-commerce architectures, you have what we call package solutions and service providers. Right. Nowadays, you can see there are a lot of application with the cloud. For example, now when it comes to keep server sites, for example, you don't really need to have your own servers where you can purchase the processing power what is available in the cloud. Now, things like companies like Amazon, AT&T, Cisco, Google, HP, IBM, Microsoft, Oracle, they provide you different products like EC2, Elastic Computing, Google, you have App Engine, Microsoft Azure, there are a lot of, services are there you to start with. Okay, the next thing I'm going to discuss about the different processing methods. So when you have processing, there could be, we can talk about two things, online and batch processing. So when you say online system, right, it continuously update files and databases, the interactions. In batch processing, on the other hand, it actually collect and then execute on some predetermined schedule, maybe every evening, or every Sunday, a particular day, and so on. Right. Now let's try to understand how this processing happens. If you look at, for example, ATM query process, you know that first of all, you enter your details, and then you can retrieve whatever the account balance. And then third one, you can verify the account, right? And also, the balance, what is on the ATM screen. So if you look at point of S post processing, we know that a lot of computerized shops are there. We have what we call the post terminals. So usually post program is an online one. Online one means like every transaction when people buy, purchase, right? You have to record it. So that information reside in the inventory. And then daily sales program batch wise, you can update like once the day ends. In evening, you can actually arrange, right? So that it works on offline, like as a batch processing. Right. There was a question on Malit on the recommended book for this module. Yes, I'm actually referring one of the books, and all these slides were based on that book. So I will share the book within the LMS so that you can read on if things are not very clear, right? But the standard text is explained. There are, a lot of details are there, but I think I have taken only topics that we need to cover for only for your module, right? But you can take some time to read the book. I will share because we have some time. The exams will start on next month. So you have about like 1 month to cover up the topics that we discuss. And then I will also share like some of the previous papers or sample questions so that you know kind of what kind of questions you might get. But as I told you earlier, most of the time, the questions that we have discussed in, online sessions and plus in interactive sessions, because we discuss more important one, the interactive sessions. So those will come into your examination. Right. So let's back to a discussion of system design specification, which is at the end of the system design phase. We have to present the complete system design with the architectural choices, right? So this is to be presented, and this is what we are going to, at the end, going to implement, right? Now that we have discussed about the system design part and we have completed the architectural choices, there are different, hardware, software setup we have available. And once we do that, the next one is we need to implement the system. So let's discuss main ideas behind system implementation. Now, so far we were discussing about the system development life cycle. We discuss system planning, system analysis, and system design. And now we are going to talk about system implementation. As you can see, the outcome of this phase will be the fully functioning system, uh, right? Now, system implementation is the fourth phase. And this phase, we will have the physical model and we need to implement. Now, when you talk about implementation, there are different tasks are there. You have to develop the application. You have to create documentation. You have to perform testing. And then you have to have training. You have to convert data, which means that sometimes the systems are manual, which means you have to make it to digital, or sometimes you change the system from one technology the other technology. So that means you have to, change the data to suit for the new system. And finally, we will talk about the system changeover, or the change of old system to new system. Right. Okay. Now, if you look at what are the steps of this phase, we will have application development. That is the main thing. And once you develop it, you test it. And then we need to install. That means we have to deploy the system where the user uses this information. And then you evaluate the system. So during the application development, analysis has to determine overall design strategy, and you have to work with those who are developing the system, which means the programmers, and you have to design code, test, and documentation. So this figure shows you briefly how we plan. So planning means overall plan. That's what we have discussed in our previous sessions. During the development, you can design what modules that you want to develop, and then you can code the module, you can test the module, and then you can document the module. Now, once you develop, you have to perform testing. So testing, there are like different test systems are there, which we will discuss later on. But usually we can talk about unit test when module level. Then when you between the module, we can talk about integration testing. Then we can, as a system, we can perform system testing. And then also we can check whether users are accepted or satisfy the system, user acceptance testing, right? And then documentation also will be there. So like in any product development, in software also, we have to make sure that we maintain the quality. So quality assurance is a essential step in the implementation phase. So there are a lot of software engineering, concepts are there, quality standards are there, but usually these standards are maintained by the International Organization of Standards, or ISO. So sometimes we talk about the ISO certification. That means for the processors, we can focus on this. And if you look at particularly the software engineering, we have a development process with the solid design and accurate documentation and careful testing. So next, let's look at what are the system development tools available. So the first one is structural development, which means we talk about data flow diagrams, and also we can focus on structure charts. And if you use object-oriented methods, then you can use case diagrams, class diagrams, sequence diagram, and transition state diagrams, and so on. Third, if you use agile methods, you can use either spiral or other iterative model. That is also possible. So when you actually develop the system, you actually going to use different tools. Now, for example, we know that when you're building system, we normally come up with ER diagrams. We can create flow charts or pseudocodes. We can also use decision table and decision trees. We already discussed in early, right? Okay, so in case if you're using agile development, customers create what we call user stories. So these user story will describe a particular feature and with some priority level as well. So the new systems are released, right, after many iterations, and usually it is test driven, testing. Um, it's carefully done by the customers. So in this one, I'll briefly show you how in agile development, what happens. So then you have, but we have user stories, and then you have some iterations, then you create a new versions, you check the tests, right? And then you can also, write user queries, right? Now that we talk about the modules part, let's look at how we can design modules and also looking at how to implement the module. So structure charts usually we use to show how the program modules and their relationships. So structure chart, you have rectangles. These rectangles normally shows you the program module. And there are a lot of errors. Now, arrows indicate other additional information, right? Therefore, we have to talk about different levels. The higher level module we call control module, or lower level module, or we call subordinate module. So structure chart, you can have different presentation programs, data couples, control couples, conditions, and loops. Right. Here is an example, the module design. Now, in this particular case, you can see here, so the module 1 will be your control module, and there are like parts, module 1.1, 1.2, and you have 1.3 as well. And then 1.1, 1.2 is below 1. We can say they are subordinate modules. And then there could be some library modules as well, where you can use frequently available functions, and that comes under library module, right? Then when we are representing these two, that means modules and with the interaction with subordinate modules. So for example, when you want to maintain customer data, one subactivity is you can look for the name. So you can write a customer name, you can send, and then you can get the customer number. Right. Now, in previously arrows, we have empty circles, but let's look at a case where we have filled circle. So this is what we call the control couple, right? So that means when we are trying to maintain the customer data, you customer status and upload customer file, but then it suggests that, okay, you should overdue. Some cases you can also represent diamond block like this. In diamond block, what you see here is it represents there's some selection. So sort inventory parts. You can select either sort by part name or sort by part number or inventory value. So depend on your requirement, you can model them. Okay, so now that we have witness the selection. So these here's are the repetitions. Now this arrow indicates a repetition. So whenever you provide, right, student number, and then this will give us the grades and also the indication of end of the file. Similarly, when you send the grades, you can get GPA. And when you send GPA listing, then you will get grade report. So what you need to remember is use of this curve arrow that is indicating you are working inside a loop. Right, some more ideas, right? Now, cohesion, we talk about model scope and processing characteristics. So if you think that the module apply a single function task, then we say normally it's a high degree of cohesion, which is desirable. Then we have coupling. Coupling means we have a relationship and interdependence among the modules. So we can normally say that they are relatively independent or loosely coupled, which is desirable. So cohesion and coupling concepts usually used in structural development, but again, you can also use them in object-oriented development as well. Right, now you can see when you talk about the coupled, you have tightly coupled. So you can send from here, we can say customer number. And then we have old balance and new challenges. And new balance is on the top. So the same way when you actually break it up to two things. So for example, applying a discount, we take it as separately and calculate the current charges. There's no change. Right. Now that we have looked at how to design these modules, let's look at how we can actually create our own structure chart. So the starting point will be data flow diagrams, which we have done early, and object model to identify processes and methods. Then we have to identify the program module and determine the control subordinate relationship. Then you add symbols and then analyze the characteristics. So according to this one, this is what we have data flow diagram that we have drawn earlier, right? So let's look at how we can convert this to structure charts. So you can see here, we have order, right? And order system, we said module 0. So what you can do is you can send picking list and you can get order. Right. So in this one, as you can see, this is what they have modeled, right? And they have separate out what is related to content diagram, then what is related to diagram, then again diagram 1 DFT. Right. Now that we have discussed about the implementation details, so let's look at the test in the system. Now, the very first thing is when you write a code, you perform testing. Usually we call unit tests. So for example, if you take Python, for example, we have what we call doc test, or even there's another framework called PyTest, which we can use to test in the system. So when it comes to programmers, they can perform various tasks: test checking, code review, unit testing. So which happens during the application development. Then we have system analysis design in the initial test plan, which include test steps and test data for integration, testing, and system testing. And usually I told you like it happens in unit test in the, but integration test is how do you handle like several modules together, right? And integration is necessary for the programs. So the final step, the system is testing for completed system. Right. Now, this diagram which shows you all possible, tests. For example, in unit level, we have unit test program. And then we are going to extend that to until test program and until test program 3, which again can be merged in case. Then you have under the unit test, you have a unit test, program 4 and program 5. And then unit test program, user test, unit test program. We have unit test program. These are the kind of testing that we can talk about. Now, 3 test are there. System testing is as a whole how you are going to test, and then whatever the blood test, and then here we can have integration set. Right. The next documentation, again, we discussed that this is very important, especially if you have custom made, the code and somebody else wants to start working on it. So you have to have some knowledge on this. Right. The first one is program documentation. So we can describe what is input, output, and the processing. Then when it comes to system documentation, we can describe how the system functions. Right? So you can include data flow diagram, object model, screen layout, and then source documents. Then we can also have operational documents. When you start working on this, we can work on operate. And the next one is you can talk about we have user documentation. In user documentation, we have instruction and information of users who interact with the system. And it also has user manuals, help screen, and also the tutorials. Right. Now that we discuss about the ideas, let's look at installation and evaluation. So when it comes to system implementation, the following are the remaining steps. So when you implement the system, remember you have to have 2 systems. One is operate and one is test. If you ask me like, why do you need a separate system environment, let me show you like here. So there's operational environments currently using the data, but there are like some test environments. So then you have to provide training for users. Again, different types of users. You have to provide training for general users. You have to provide training for managers and the IT staff. Third, if you want to convert some data, yes, we can work on it. You should be able to perform data conversion and system development. Then finally, you can also have a post-implementation evaluation, and then you present your final project report to the management. Right. Now that we talk about the implementation and testing, right? So we need to establish, or we need to start the operational environment. Operational means data actively used. So the operational environment, you have live data. And this can be accessed only authorized users. Right. Training. Anyone who interact with the new information system, you have to provide enough training experience to improve a person's role and skills. So usually IT department is responsible, and then software or hardware vendors, professional training organization. So they also can provide different training. So you can see some information on what kind of a training provided for users, managers, and IT. Data conversion, we already discussed the idea. So the data conversion means the existing data you have to put into the new system. So that could be something like you have to done manually, or then you can use it, the data from old legacy system to new system. Right? Okay. The next one is system changeover, meaning like implementation. So for example, direct cutover means like you directly implement the new system, you discard the old system. Second, parallel operation. So that means you can operate both the old and the new system. And then after some time, you can decide on the new system. Third, pilot operation. So which is a specific group, right? And they use the system for a period of time. And then when you say system process successful, then you can implement throughout the organization. Then finally, phased operation. You can do some work phase by phase, like what we have right now. We have, let's say, in the COVID, for example, sometimes when they want to test medicine, they do it only for Colombo, then they, as a next step, implement it other. So this is called phase operation. So here are the graphics which shows you how old system and new systems start with. Direct cutover means you finish old system and you start with the new system. Parallel, there could be some overlapping, but you still work on it. Pilot operation, for sometimes very small number you use. In this particular case, old system and new system, when you say pilot, we will perform it to one place and then you extend the other places. Final one, phased operation, you can see phase by phase, you are switching from old system to new system. Right, now, any method, there are some advantages and disadvantages. Now, if you think about the costs, direct cutover is the lowest cost possible. Pilot operation, phase operation, but parallel operation will be the highest cost. Then we have low, medium, and high about the risks. So again, we have to decide, right, which operations that we need to perform, and accordingly, you have to plan for that. Right. Once you have developed the system, we call post-implementation, you can see the accuracy, completeness, timeliness of the information system. You can check whether users are happy. You can check whether the system is reliable and maintainability. Right? Next, you can have adequacy of system controls and security measures. Then hardware efficiency and platform performance. Effective of database implementation. Performance of the IT team. Performance and quality documentation, policy and quality and effectiveness training. And then we have accounts for cost benefit estimate and development schedules. And finally, once you do that, you have to again report to the top management. And here you have to talk about like what is the total project cost will be. Right. Last topic. So under the system support and security, we are going to discuss the issues that might face, because when we develop, you might not think what might happen in the future. But support, security and support, you have to focus on that, right? So system support and security, you can say that it's the final phase of the development cycle, and you will get a fully functional system, right? So there are a few things that you can focus on. You can focus on security issues, protect the integrity of the system and data, and any signs of obsolescence, which means after some time you have to throw it away, the software, and you have to start from the beginning, right? So we also discussed earlier that how the cost will be. Operational costs, usually they are fixed, but the other one, there were a lot of things that we need to discuss. Right. Now, when it comes to operational cost, we have to include suppliers, rentals, the softwares, and especially different types of software releases. So we can use activities, you can change programs, you can change procedures, documentation. So that will improve the correctness and also the performance of the system. So when you look at different types of maintenance tasks, now once we have developed, we can corrective maintenance to fix errors, adaptive maintenance, you can add new capability, new features, perfective maintenance, you can improve the efficiency, preventive maintenance, you can reduce the possibility for future system failures. So corrective maintenance project, usually you can have a user or IT staff member reports a problem. Adaptive mainframe project usually use to respond user requirements, and improvements in the meet changes the business or operating environments. Automated program restructuring and re-engineering are forms of perfective maintenance. Sometimes you have to use those techniques. Last one, if you want to avoid any future problems, IT staff, we need to perform what we call preventive maintenance, right? So you don't wait until something happens to you, right? Even before that, you can start. Maintenance management, system maintenance, you need management, quality assurance, and also you have to have cost control. To achieve these, we can use various strategies: maintenance team, maintenance management program, configuration management options, and management release procedure. So these basically maintaining the management. Then maintenance team, usually you have one or more system analysis and programmers, right? And usually many IT departments, they organize their own set of hackathon, right? In this particular case, IT department, you have organized into separate new development and maintenance groups where staff members are rotated from one group to another. Okay, let's talk about something called configuration management. Is a process for controlling change in the system requirements during software development. And this configuration management is very important, managing system changes. Then system performance management. System performance, we can use various ideas, things like response time, bandwidth, throughput, turnaround time. So these comes under as system performance. Then we have what we call the case tools, which include system evaluation maintenance features, and you can use during the system operation, security, and support. Okay, let's briefly discuss about the system security. Security is a vital part in any system, and it's also depend on comprehensive security policy, a document which tells you how exactly you maintain the security within the organization. Second one, you will have risk management. Again, when we have multiple projects, you have to decide which projects to continue, which involves some risk, right? So you can use it to identify, analyze, anticipate, and reduce risk. Right. So let's look at risk identification and risk assessment. How do you identify a risk? Right. Now, risk identification, we have software, hardware, network, people, procedures. And then you have risk managers, which identify any issues and how they might, use it to solve this. And you have to perform risk assessment, which is risk is the impact of the attack multiplied by the likelihood of vulnerability being exposed. So this is called risk assessment. Then we have risk control strategies. You can eliminate risk by providing protective safeguards. Mitigation, so to reduce the impact of the risk by carefully planning and preparation. Transfers, you can shift to another asset or the party. And finally, you can have acceptance. Then we can also talk about the security level, especially in a system. We can talk about physical security, which means in physical environment, you can have locks in the doors, and then you can have, reverse around the centers, and maybe you can use other means to physical secure. Then network security, especially encryption, right? So we can talk about how the network security is affected. Then we have application security, which is understanding the services and application permission, things like that. Then file security, you can use encrypt and also provide permission, which you can use to read the files. Then we have user security, which identify management techniques, comprehensive password protection policy. Especially, we tend to use the same answer. And finally, procedural security, manager control and policies that ensure secure operations. Let's look at the backup and recovery. You know that any system, we have to make sure that once it's operate, we want to keep track of data. Therefore, you have to talk about backups and recoveries, right? So basically, backup means you are creating copies of whatever the data, and the recovery is restoring data, right? And then overall backup and recovery plan we can prepare. So, and this is known as disaster recovery plan. And you can also have what we call the backup policies, which can tell you more information how to backup and when to backup. All these should be there within the backup policy. There are many backup media you can use. We can use tape, hard drives, optical drives, right? And then you can use, chips, backup media. And also you can use cloud-based storage. Then we can talk about backup types. Now, for example, when you want to back up your existing database, you can create a full database, which is you copy each and every file in the system. Two, you can have differential backup, which is up to the last file, right? And then incremental backup, you can keep on increasing, or you can back one at a time. Continuous backup, you have a real-time streaming method, which you can record all systems activities. Okay, so the next one is different terminology. I don't think we can talk about this. Okay, but let's briefly discuss about the type of, the backups we are using. Full backup means it will back up everything. It's a slowest backing up time. The frequency is monthly or weekly. Let's look at another one. Incremental, where we will use backups to files that are new or changed since the last backup of any kind. And what we are getting is daily or more. Right. Next one, we need to talk about the retention period. So backups we keep in some place, because make sure that you are not going to store in the same place, should be somewhere else. And it should be secured, it should be protected, it should be inventoried, periodically. Okay, whatever all these management system becomes obsolete, which means after some time you cannot make use of the system. Now, for example, here you can see how people have used punch cards, which was very popular. But now we are not actually using, punch cards. Right. Okay. So that's, I think, what I need to cover for the today's session. With that session, we finish our theoretical part of the module. What is left is we need to complete one more interaction session for you guys, where I will talk about structure charts, where we will use the structure charts to develop the module outline, which I will do as a interactive session tomorrow. Right. Okay. So now I think with that said, let me finish for today's session. But before that, let's have the attendance. So let me share. Okay, guys, this attendance system is not working. I'm getting an error, bad gateway. So let's finish for today. I will take your attendance through the Zoom. Let's meet on the interactive session. And I will also share the book so that you can start going through the material.